Hi, my name is Stuart Lynch. In today's video, we're diving into something essential for any iOS developer, and that's colors in SwiftUI. In SwiftUI, a color is a view used to display a rectangular area of a specific color, and it's not just a data struct for color values like a UIColor in UIKit. Instead, it's actually a view component that conforms to the view protocol. And this makes it more than just a way to define colors. It's a lightweight and flexible way to fill parts of your SwiftUI interface with color. So whether you're designing a simple app or a complex user interface, colors play a huge role in enhancing the look and feel of your design. They can guide users, set the mood, and make an app stand out. But did you know that SwiftUI gives us multiple ways to define and use colors? From built-in static colors like primary and secondary to creating custom colors using RGB or HSB, and even hex values. The possibilities are actually endless. I'm also going to cover how to access UIKit colors that aren't directly available in SwiftUI. And yes, you can still use your favorite UIColor system teal in a SwiftUI project. And on top of that, I'll show you how to adjust colors dynamically for light and dark mode, and make your app look amazing no matter what theme your user has set. So whether you're a beginner just starting out or an experienced developer looking to sharpen your skills, this video will give you everything that you need to master colors in SwiftUI. So let's jump in. I love getting your feedback, so tap the thumbs up button if you enjoyed this video and leave a comment below. Make sure you subscribe to the video and ring that bell to get notifications of new videos. And if you want to support my work, you can buy me a coffee. I have a starter project for this video, and I encourage you to download it from the link in the description. You'll be using the starter project branch. The completed branch contains the completed source code. So just download the zipped archive for the starter branch and start from there if you're working along. In the end, you'll have a reference that you can refer back to in the future. I have 8 sections as views, and we'll be working through them one at a time. The content is a start view that has a picker, so if you install the app on your phone, you'll be able to get to each view. I'm using an enum that conforms to the identifiable, case iterable, and view protocols, where we have a computed property for the picker selection string, and the selection is bound to an instance of this enum, and since it conforms to the view protocol, we can display a view based on the selected case. Now that's all besides the point, and not relevant to this video, but I thought you might like to see how I did this. So the first thing that we can look at is the simplest. When you type a color and then a period, you get code completion showing you a number of static properties for the color view struct that are suitable for UI elements, and they're standard colors. So let's present the first one, which is blue. What you end up seeing in this view is actually a 2-column view, with the left column showing how the color looks in light mode, and then on the right, how it's shown in dark mode. And to facilitate this, I used a new feature of iOS 18 that lets me create a custom container view, and that's going to allow me to loop through all subviews. And I call this the split color scheme. You can see that I created an H-stack to display each of the section views, and each one uses a different color scheme. The section view itself is a V-stack with a for each loop that presents the section header followed by the content provided, which is the color.blue, that is our content in this case. And you can see that there is a slight difference in the color between light and dark mode. Now I want to see what they all look like, so let me add color.black. Now these are all static properties of the color view struct, so if I copy the color dot, I can easily enter them all below the blue view, but I'd like them to be in alphabetical order, so I'm going to move this black up before blue. Now for the rest of the colors. They are brown, clear, cyan, gray, green, indigo, mint, orange, pink, purple, red, teal, white, and yellow. That's it. Our standard colors are now displayed in light and dark mode for comparison. Well, in addition to standard colors, SwiftUI offers two semantic colors, and these are primary and secondary. And as you can see, the primary color in light mode is black, and that is used as the default for text views strings. So when in light mode, they're black, but when you switch to dark mode, they're white. And that secondary color is a gray color, and you can see that there is a slight difference between that gray in light and dark mode. I have an app called Digital Color Meter that I got off the App Store, I guess, and I can show you this. As I roll over the gray, you can see that the RGB values are different for light versus dark. Now, black is black and white is white, though. The gray, though, as you see, is slightly different in light mode over dark mode. If you come from UIKit, you'll know that there are a ton of other colors that you can use for UIColors. And I have a link here that takes you to the Apple documentation where you can see this. Now, these are not static color properties, though. So you will have to use a color view initializer that specifies that you want to use a static UI color. And these are adaptable colors which adapt to the current trait environment, as well as the adaptable gray colors. There's also a transparent and fixed colors. So let's take a look at these. Well, I can create an instance of a color view and provide the UIColor label here for the argument, and provide one of those static UI colors like System Blue. Now, if I bring back my color meter, you can see that the colors do adapt to the different color traits slightly. It turns out that as a shortcut, we don't even need to provide the UIColor label. We can simply provide the static UI color like this. Now, as these are all system colors, I'm going to copy the color, the left parentheses, the dot, and system string to my clipboard so that I can quickly enter the remaining ones. So these are brown, cyan, green, indigo, orange, pink, purple, red, teal, and yellow. So moving on to the next section, we can see that there are a number of system grays. In fact, there are 7 of them. So after creating the first one, let me duplicate that 6 more times and simply add a version number to the end. And if I scroll on the preview here, you can really see the trait differences here. Now, like static SwiftUI standard colors, UIKit has their own set of fixed colors. So let me start with a special one that is clear. And I'll take a look at that in a minute, but first let me add the remaining. There is black, blue, brown, cyan, dark gray, gray, green, light gray, magenta, orange, purple, red, white, and yellow. So if I scroll to this section, we can see that the clear color is just that. It's clear. However, it does allow us to present a view that will consume as much space as is available, but not affect the view appearance at all, and will display any underlying content, which in this case is the background. Now, you may be wondering if the static UI colors are the same as the static SwiftUI color views. Well, let me check out this green color, as I know it's in both. So with my color meter, I can first check the colors here for light and dark. Now, if I switch to the SwiftUI standard colors and take a look at that green there, as I roll over those 2 trait versions, I can confirm that they are identical. So moving on, in SwiftUI, there are static properties for UIColor that are standard colors that are used for different UI elements. And these are used in SwiftUI like for the background or a label or a group background, but there are no static properties for these color views in SwiftUI. And you can see these by checking out this link here. So let me make a list of these for reference so that you can see how many there are. Well, there are 4 different label colors. There's the standard dot label, which is black or white, depending on the color scheme. But there is also a secondary, a tertiary, and quaternary labels. Similarly, there are 4 system fill colors. There's the regular system fill. And again, there is a secondary, tertiary, and a quaternary version as well. There is a single text color, and that is the placeholder text. And this is used for placeholders in text views, for example. There are 3 different system background colors. The standard one is the default, where white is for light background and black for dark mode. And that's what you're seeing behind each of those columns. But there is also a secondary and tertiary versions, but no quaternary. There are 3 grouped content background colors for things like groups or forms. And these are system group background. And there is a secondary and tertiary version here as well. List separators have 2 versions. There's the standard separator, but there's also an opaque separator. And when you create a link view, the link gets the UIColor link static color, which is that familiar blue. And then finally, there are 2 non-adaptable colors. One is for text on a light background, and that's the dark text. And the reverse light text for text on a dark background. And this is different from the label color. Well, you can also construct colors by supplying different component values. For example, if you wanted to supply the RGB values, where you have the red, green, and blue, which are values between 0 and 1, you can do that. So for the color red, we have the value for red being 1, and green and blue both being 0. And you also have the ability here to provide the opacity. But we also will have a view modifier where we can specify opacity as well. If you prefer HSB, or hue, saturation, and brightness, where each is another value between 0 and 1, you can also do it that way. So to create red, the hue is 0, but both saturation and brightness are 1. Again, you could supply opacity. Now, what's missing is a hex constructor. Now, fortunately, you can create your own extension for that, and I've included an example one here in this project. And it accepts a string with either the hash or without it, and that will convert a 6-character hex string into a color view. So the color for red is hash FF0000, so we can create that same view here. Now, these are pure red colors. How do they compare with the SwiftUI color of red? It may not be obvious here, but there is a difference. I'm going to bring back my color meter here, where I can see that. But I'm going to need to switch the display to native values. And you can see that all of our components use a 255.00, which is pure red. So 255 out of 255 is 1, which is that value that we supplied. Both the static and SwiftUI red and UIColors are not, though. And they also change between light and dark, though both are identical for each trait. There's one final component struct, and that is to supply a white argument, where 1 would be completely white and 0 would be completely black. So if you provide a value between 0 and 1, you get a different shade of gray. And of course, you could supply opacity here too. Well, we also have the ability to access color assets. And if you go to your assets folder, you can see that there is a placeholder for accent color. And if you select it, you see that there is a placeholder for a universal color. If you reveal the inspector, you can change the appearance to be any and dark, which is essentially light and dark. And now you can bring up the color panel and choose a color for the accent color, which will be all of your buttons, etc., and choose your own light and dark versions. Well, you can also add your own color assets by tapping the plus button at the bottom and choosing a new color set. Well, I'm going to give the color a name like app color. And notice that I'm using a capital A and the word color here is at the end of that string, because that's something that I find strange, as you will see. So let me specify colors for that asset. I'm going to return to our asset view now, and I want to use those colors. I can access the accent color by using the SwiftUI static accent color. And I can see it's now orange. If I had not defined that color, it would have been the standard blue. If I want to use the UIColor version of this, it's called tint color. Now here's the strange part. I like to use that new app color, that asset that I created. If I try to use that and start with a capital A for the static property and the word color, it's not here. But there is this lowercase app, APP, that you can see, and it's referencing the app color asset catalog color. So it's making it lowercase, and the color string is removed. But that's definitely my green color. Let me go back to my asset catalog and create one more color. And this time, I'm just going to call it lowercase theme. And I'm going to reveal the inspector and make it universal. So the appearance is none. And let me just pick a color. So I've left off the capital and I've left off the color at the end. When I go back to my view, then I can create that color just by using the theme name as a static property. The next way to construct a color view is somewhat buggy in Xcode, but once you have it, it's actually pretty cool. I have a comment here that explains the process that works for me. What you can do is start by typing the color struct initializer, but as an argument, use a hashtag ColorLiteral followed by the left parentheses, but don't close the parentheses. And as soon as you do that, you see that we get a blue color square, which is a picker, displayed with some strange image of a cloud in the middle. That doesn't matter. Just double click on this and a color picker appears where you can select from a color swatch or you can select from the actual picker itself. So once you've done that, you can close the parentheses off and now you have a color view with that selected color. So let me show you how this can be particularly useful. In iOS 18, we were introduced to mesh gradients. And I have a full video on that topic, so I'll leave a link in the description. Now, it's not important to really understand that for this video, but suffice to say that when you create a mesh gradient, you provide a grid of points. So for example, a 2x2 grid, and the points are the four corners of that rectangle in a 0 to 1 coordinate system. So then I can create an array of colors that can be applied to each point. So I'm just going to copy that color view, and I'm going to create four variables using that view, representing the four corners. So top left, top right, bottom left, and bottom right. And then I can go to that array and add those four colors in the array. Now, because they're all the same color currently, nothing will change for that view. It's just a solid color. However, I can now go back to those colors and just double click on each one, and it'll bring up a picker, and I can either choose a different swatch color, or I can even bring up the full color picker and choose a color from here any way that I'd like. This way I can now experiment to get the best mesh gradient view that I may want to use in my own projects. And for the final view, I want to show you perhaps a couple of modifiers that you may not be aware of. So let's just start with the color purple as the SwiftUI color view. Now you probably already know that you can apply an opacity to a view with a range from 0 to 1. Well, did you also know that you can apply a brightness modifier with the same range of 0 to 1? And there's also another one called grayscale, again with the same range. So there's a lot to work with here, but I want to finish with just one more quick example, and that's of mixing colors. And again, I have a complete video on this topic as well, so I'll leave a link in the description. You can start with any color and use the mix method on that color by providing another color to mix with and by specifying by how much. Finally, remember that initial start view, and that's where we get displayed when you run this on a device. Well, now that I've flushed out all of these views, I can see how I can move easily from one view to the other using that picker. It's a handy resource representation. If you found this tutorial helpful, please give it a thumbs up and leave me a comment. You can subscribe to my channel to get notifications of new videos. And remember that you can also download my YouTube channel listing app for free and quick access to all of my 350 plus YouTube videos. A link's in the description. And also remember, I have a full SwiftUI course available on my Teachable site where you learn how to build a fun, multi-targeted app.